In question 5, we're told domestic users in the UK are supplied with mains electricity at a root mean square voltage of 230 volts. In A, we need to state what is meant by root mean square voltage. Well, the root mean square voltage is found by calculating the square root of the mean of the squares of the voltages throughout the cycle. It gives the equivalent power of a DC supply. In B part 1, we need to find the peak value of the supply voltage. Well, the RMS value is given by the peak value over root 2. So rearranging for the peak value, putting in the 230 volts given in the question, gives 325 volts. In part 2, we need to find the average power dissipated in a lamp connected to the mains supply when the RMS current is 0.26 amps. Well, power is current times voltage, and we have 0.26 amps at 230 volts, giving a power of 60 watts. In C, we're told the supply has a frequency of 50 Hz, and we need to add to the voltage against time axes a graph of the waveform. Well, first to find the time period is 1 over frequency, which is 1 over 50 Hz, 0.02 seconds or 20 milliseconds, as the x-axis on the graph is given in milliseconds. We can then add a scale, for instance going up in 2 milliseconds per division, and the value of the voltage needs to go to at least 325 volts, and then we get a graph something like this, with a complete cycle taking 20 milliseconds.